Welcome back, dear listener. I'm your sleepy scientist. Have you ever wondered if our universe, the stars above you, the ground beneath your feet, even the thoughts in your mind could all be part of a simulation? It's a question that feels almost too big to strange, and yet it lingers in the quiet corners of late-night conversations. Tonight, we're not just asking what the universe is made of. We're asking something deeper. What if it isn't what it seems at all? Because here's the problem we're going to explore. If one day humans could build a computer powerful enough to create entire worlds, complete with laws of physics, galaxies, and maybe even conscious beings, then how could we ever be sure that we aren't already inside one? Stay with me, and together we'll drift through the science, the imagination, and the wonder of what it would take to simulate a universe step by step, layer by layer, until the line between reality and possibility begins to blur. Imagine lying down beneath the night sky, the stars scattered above like diamonds on velvet, each one burning with a story older than human memory. You feel the stillness of the night, the hush of the world when it begins to fall asleep, and in that silence, a thought quietly rises. What is this place we call reality? And why does it feel so impossible to grasp? We live inside this vast structure called the universe, yet we barely understand its edges, its origin, or its true nature. And here, in the 21st century, another question quietly knocks on the door of human thought. Could we simulate all of this? The idea may sound like a plot pulled from a science fiction movie, but it is rooted in serious discussions among scientists and philosophers. When you think of a simulation, you probably think of a video game, a world inside a computer. But what if a simulation could be as real as the world you're experiencing right now? Could everything you see, everything you touch, even the thoughts you're having this very second, be generated by rules, numbers, and code? This is the cosmic problem, the one that keeps tugging at our imagination. Are we the original reality, or are we already characters inside someone else's universe? For thousands of years, human beings have asked, what is real? Ancient philosophers in Greece and India speculated that the world we perceive might just be shadows on a wall, or illusions crafted by the mind. Centuries later, physicists discovered that reality is stranger than it appears, that particles can be in two places at once, that observation itself seems to change the outcome of experiments. And in our own time, computer scientists have shown us that artificial worlds can be built, populated with characters, landscapes, even forms of intelligence. When you combine these threads together, the question feels less like fantasy and more like an inevitable thought experiment. If we could simulate a universe, how would we begin to understand the cosmic problem? Let's think about scale. Imagine shrinking yourself down into the world of a video game. The mountains, rivers, and cities around you look solid. The people you meet inside the game move, speak, and act as though they are alive. To the characters inside, the world feels real, but from the outside, you know it is simply code running on a machine. Now, imagine if our universe is something similar. Not a crude video game, but a simulation so rich, so detailed, so vast, that the beings inside it could never tell the difference. For us, gravity feels like a fundamental law. Light feels like the natural rhythm of space. But what if these are just the programmed rules of the system we inhabit? This problem isn't just about science. It touches on something deeply human. We wake up every morning believing the ground beneath us is solid. The air we breathe is real. The people we love exist outside our minds. But if the universe is a simulation, then those certainties are not quite what we think they are. They are the product of deeper rules, invisible structures, maybe even choices made by whoever designed the system. And here's the truly unsettling part. If reality can be simulated once, then it can be simulated again and again. There could be infinite layers of simulated universes, each one stacked inside the other, like mirrors facing mirrors, stretching forever. For a listener in the United States, this question often takes shape against the backdrop of technology. America has always been a land where science and invention push boundaries. The internet, artificial intelligence, quantum computing, these are not distant ideas. but living projects that shape daily life. And so the simulation question feels personal. If our own computers can generate immersive virtual worlds, how far could technology go in 100 years, in 1,000 years, or in 1,000,000? Somewhere out there, in the vast sweep of cosmic time, might a civilization become so advanced that simulating an entire universe becomes possibly the cosmic problem is not only about possibility, but about perspective. If we could simulate a universe, then what is the difference between simulation and reality? Suppose a simulation contains galaxies, stars, planets, and life. Suppose it contains consciousness, beings who laugh and cry, who wonder and dream, who make art and fall in love. To them, their world is real. They would have no way of knowing it was born from a machine. So when we ask if our universe is simulated, we are not only asking a scientific question, but a philosophical one. What does it mean for something to be real? Does reality depend on its origin, or only on the experience of living it? Think of the American dream, the idea that life is about striving, reaching, building something greater than yourself. That dream rests on the belief that the world around you is solid, that your actions matter, that your story is written into the fabric of a real universe. But if we are inside a simulation, the dream does not vanish, it simply changes shape. Your story is still real to you, still filled with meaning, even if it is running on a vast cosmic processor somewhere beyond your reach. And maybe, just maybe, the purpose of the simulation, if it is one, is to explore what beings like us will do when given the gift of existence. Cosmic problem, then, is not meant to frighten us, but to awaken a deeper sense of wonder. Instead of closing doors, it opens them wide. It makes you look at the stars with fresh eyes, wondering if they are burning spheres of plasma or lines of brilliant code. It makes you question whether your thoughts arise from neurons or from some deeper computational structure. And it forces us to think about the future. If humans could one day simulate universes, what kind of responsibility would we carry for the lives we create inside them? This is where our journey begins. By asking how to simulate a universe, we are also asking who we are, where we belong, and whether existence itself is something more mysterious than we ever imagined. The problem is not just about technology, just about philosophy, but about the very ground of reality itself. When you lie awake at night and feel the quiet pulse of life, remember that the question we are about to explore is not far away, is woven into the fabric of your own awareness, whispering softly, what if this world is already a simulation? And we are only beginning to notice when we begin to speak of simulating a universe. The very first challenge is to understand what we mean when we use the word universe. It is a word so common that we hardly stop to question it, yet it contains within it all of space, all of time, every particle, every law, every thought you've ever had, every dream you've ever dreamed. The universe is not simply a place. It is not just a collection of stars, or galaxies, or planets. The universe is the totality of everything that exists. And when we talk about building a universe, even a simulated one, we are asking ourselves, what must be included for something to deserve the name universe? Think of the simplest definition. A universe is a container for reality. It has a stage, the vast expanse we call space. It has a rhythm, the flowing sequence we call time. It has rules, the principles of physics, mathematics, and logic that determine how things move, change, and interact. It has actors, atoms, particles, fields, energy, and eventually life. To simulate a universe, one must recreate this whole structure not just in appearance, but in essence. It is not enough to paint a picture of a galaxy or animate a sun rising over a horizon. To simulate a universe is to construct a system where galaxies emerge on their own, where stars ignite because the laws of physics make them ignite, where life arises not because it was planted, but because the environment allows it to bloom. Difficulty of defining a universe becomes clear when we ask what the minimum requirements are. How simple can a universe be and still be called a universe? Is it enough to have space and time? If so, what kind of space? What kind of time? Must there be matter, or can there be a universe made entirely of energy, or even one made only of information? Could a universe exist without observers, or is the very idea of a universe tied to the awareness of those who inhabit it? These questions are not only theoretical, they are practical for anyone who dares to imagine simulating reality. Because before you can build, you must define what it is you're building. In modern physics, we often think of the universe in terms of fundamental constants. There is the speed of light, the strength of gravity, the charge of the electron. These numbers are not negotiable in our universe. They are stitched into its fabric. If you change them, even slightly, you get a very different kind of universe, perhaps one where stars never form, or where atoms cannot exist. So one way to define a universe is by its set of constants and laws. This is the operating system of reality. Just as a computer game cannot run without a set of rules coded into its program, a universe cannot exist without laws that determine how its contents behave. To simulate a universe, then, is to write its laws into being, to create the architecture that allows complexity to rise from simplicity. But there is another layer to the definition of a universe, one that touches not only science but philosophy. A universe is not just what exists out there, it is also what exists in here, in the minds of the beings who experience it. If there were no conscious observers, would there still be a universe, or would it be empty mathematical possibility, unobserved and unknown? Some physicists argue that reality itself requires observation, that without consciousness, the equations of quantum mechanics never collapse into tangible outcomes. Others argue that the universe is objective and exists whether anyone is there to notice it or not. For the purpose of simulation, this debate becomes crucial. If you build a universe with no conscious beings to experience it, is it really a universe, or is it just a sandbox of numbers running silently on a machine? American imagination has long been fascinated with definitions. What does it mean to be free? What does it mean to dream? What does it mean to live a good life? Defining a universe is a similar act, but on a cosmic scale. It requires us to ask not only what is necessary, but what is meaningful. A definition that includes only physics may give us a sterile machine. A definition that includes consciousness gives us a story, a drama, theater of experiences unfolding across time. To simulate a universe, then, may require not only the coding of particles and forces, but the conditions for awareness, for beings who can love, wonder, and ask questions about their own existence. Time, one of the most mysterious elements of any universe. In our world, time feels like an unstoppable river, carrying us from past to present to future. Yet physics suggests that time may be more like a landscape, where past and future coexist, and our experience of now is simply the way we move across it. If you were to simulate a universe, how would you design time? Would it flow in one direction, as it does for us, or could it loop back on itself, allowing civilizations to rise and fall again and again? Would time be discrete, ticking like the frames of a film, or would it be continuous, a smooth unfolding without edges? The way you answer that question shapes everything else in your simulated world, because time is the canvas on which all stories are painted. Now, consider space. Our universe feels vast, stretching billions of light years in every direction. But in a simulation, space does not have to be infinite. It could be finite, a closed loop where traveling far enough in one direction eventually brings you back to where you started. Or it could be infinite in appearance, but actually compressed through clever algorithms that make it seem larger than it is. The definition of a universe does not require true infinity, only the illusion of it for the beings inside. The stars above might stretch forever, but perhaps they are only as large as the simulation needs them to be, generated on demand as the observer looks further into the distance. Matter is another puzzle. In our universe, matter is built from particles, protons, neutrons, electrons. These particles form atoms, atoms form molecules, and molecules form the substances of everyday life. But is matter essential to a universe, or is it just one way reality can manifest? Could there be a universe made entirely of waves, or strings, or patterns of energy? Could a universe exist as pure information, with no solid matter at all? If the fundamental requirement of a universe is structure and interaction, then matter is just one possible solution. In a simulation, matter could be anything the rules allow, as long as it creates the richness and variety necessary for life and complexity to emerge. And so we see that defining a universe is not a simple task. It is a balancing act between physics and philosophy, between necessity and possibility. A universe must have laws, but which laws? It must have structure, but what kind? It must have time, but how should it flow? It must have space, but how vast should it be? It may need consciousness, but how would consciousness arise? These are the questions that lie at the heart of the problem, and they remind us that the word universe is not just a label for what exists. It is an idea, a framework, a set of conditions under which reality itself can unfold. If we are to simulate a universe, we cannot begin with galaxies or planets or living beings. Those are the grand symphonies of creation, the finished works of art. To build a universe, one must first gather the raw materials, the simplest elements from which all else will unfold. Just as a house begins not with walls but with bricks, not with roofs but with beams, a universe begins with building blocks that seem invisible to us in daily life, yet carry within them the possibility of everything. These are not blocks you can hold in your hand. They are the silent actors that move behind the curtain, the pieces of a puzzle we call reality, and they must be carefully chosen if we are to create a convincing simulation in our universe. The first and most fundamental building block is information. Before matter, before energy, before the stars themselves, information is the language of existence. Some physicists have suggested that reality is not made of particles but of bits, the smallest units of knowledge, yes or no, on or off. This is a radical way to think, because it means that everything, the heat of the sun, the pull of gravity, the curve of your own hand, could be described as patterns of information flowing through a cosmic system. For a simulation, information is not just useful, it is the foundation. You cannot program a world without information, and so the first brick we place in our simulated universe is the code, the unseen tapestry of numbers that give rise to form and motion. From there we need laws, rules that tell the information how to behave. A simulation with no rules is chaos, random numbers with no structure. But when you introduce laws, something extraordinary happens. Patterns emerge, order arises, and with order, complexity begins to grow. Imagine you are programming the simplest possible rule. Every time a particle moves, it moves according to gravity. Suddenly, matter begins to clump together, stars begin to form, planets begin to orbit, all from a single law. Add more laws, and you get more richness, electricity, magnetism, nuclear forces. These invisible frameworks are the scaffolding on which the entire simulation rests. Without them, there is no universe to speak of, only static, noisy afterlaws. We must consider the entities those laws govern, the particles and fields that populate our simulated cosmos. In our universe, the building blocks are quarks and leptons, protons and electrons, waves of energy and fields that ripple through space. They may seem impossibly small, yet together they create the table in front of you, the air you breathe, the stars above your head. For a simulation, we do not need to copy these particles exactly, but we need something like them, something simple enough to be combined into complexity, yet versatile enough to generate the astonishing diversity of forms. Perhaps they would not even be particles at all. They could be mathematical nodes in a grid, or pulses of energy in a lattice of spacetime. The important thing is that they provide the raw clay from which everything else is sculpted. Next comes interaction. Building blocks alone are lifeless. You can have bricks, but unless they interact, you will never have a wall. In a universe, interaction is what creates chemistry, biology, and eventually consciousness. Particles must attract, repel, merge, split, dance together in endless combinations. Without interaction, there is only emptiness. But with interaction, there is evolution, a process by which simple things can give birth to complexity. To simulate a universe, then, we must design not only the blocks themselves, but the ways they can touch each other, exchange information, transfer energy, and transform into something new. This is where the magic begins, because from a few simple interactions, infinite possibilities are. A second cider, the analogy of music. A piano has only 88 keys, but through the interaction of notes, you can play an infinite number of songs. In the same way, a universe may have only a handful of fundamental particles and forces, but through interaction, they create galaxies, oceans, forests, and human minds. The building blocks are simple, the combinations are endless, and the wonder of a simulated universe lies not in the complexity you program directly, but in the complexity that emerges when the building blocks are left to evolve under their own rules. Another essential building block of simulation is energy. In our universe, energy is the currency of change. It fuels the stars, drives the winds, animates the cells of living creatures. Without energy, nothing moves, nothing grows, nothing transforms. In a simulation, energy does not need to be identical to what we experience, but there must be something that plays its role. A reservoir of potential that allows the system to evolve, to flow, to become. Energy is the heartbeat of existence, the invisible current that makes reality dynamic rather than static, and any convincing universe must have it woven into its design. But energy alone is not enough. To make a universe, you also need structure. In our reality, structure comes from space-time, the fabric that holds everything together. Space is where things exist. Time is how they change. Without space, there is no place for particles to move. Without time, there is no story for them to tell. In a simulation, space and time may be artificial constructs, grids of numbers, or loops of computation. Yet they serve the same purpose: to give the building blocks a stage, to allow the laws to unfold across a canvas. Defining this stage is one of the most profound choices a universe builder must make, for the nature of space and time determines the nature of everything else. Then comes randomness, an often overlooked building block. At first glance, randomness feels like a flaw, a mistake, something to be avoided. But in a universe, randomness is what gives birth to novelty. It is the roll of the cosmic dice that allows stars to form in different places, species to evolve in different ways, ideas to spark in different minds. Without randomness, a universe would be a sterile machine, predictable, repetitive, lifeless. With randomness, it becomes a fountain of surprises, each moment slightly different from the one before. In simulation, randomness is not truly random, but generated by algorithms, yet it can still play the same role, to ensure that no two galaxies, no two lives, no two thoughts are ever completely the same. The final building block is emergence. This is not something you program directly, but something that arises naturally from the others. Emergence is the phenomenon by which simple rules give rise to complex behaviors. It is the way particles become atoms, atoms become molecules, molecules become cells, cells become brains, and brains become consciousness. Emergence is the secret ingredient that makes a universe feel alive. It ensures that the whole is always greater than the sum of its parts, that new layers of reality blossom from the old. To simulate a universe is to create the conditions for emergence, to let complexity unfold naturally, without scripting every detail. When we step back and look at all these building blocks together, information, laws, particles, interactions, energy, structure, randomness, emergence, we begin to see the outline of what it would take to simulate a universe. Each block by itself seems small, almost trivial, but when combined, they form a system of staggering richness. A single law can create a galaxy. A single particle can give rise to an ocean. A single random fluctuation can spark the chain of events that leads to life. The building blocks of simulation are humble, yet from them comes the possibility of everything we know and everything we can imagine. When we try to imagine simulating a universe, sooner or later we arrive at the same doorway, a doorway carved not from stone or steel, but from numbers. That doorway is mathematics. It has been called the universal language, the language of the cosmos, the code in which reality itself is written. If the building blocks of a universe are particles and forces, then mathematics is the grammar that makes them speak. Without mathematics, there is no order, no predictability, no way to bind the chaos of existence into a structure we can call a world. To simulate a universe, we must first understand that mathematics is not just a tool we use to describe reality. It may be the very fabric of reality itself. Think of the way we use mathematics in daily life, often without noticing it. The clock on your wall ticks in seconds, minutes, hours, each one a slice of time defined by numbers. The road you drive is measured in miles, the food you cook in ounces and grams, the money in your wallet in dollars and cents. But mathematics does not stop with human convenience. The Earth orbits the Sun in an ellipse that can be described by equations. The way an apple falls from a tree can be predicted by Newton's laws. The shape of a rainbow follows precise mathematical curves. Everywhere you look, beneath the surface, mathematics is quietly at work, stitching patterns into the tapestry of reality. This is why many scientists have come to believe that mathematics is not invented, but discovered. It exists whether or not humans are here to notice it. If you were tasked with designing a simulated universe, you would not begin by drawing pictures or painting landscapes. You would begin by writing equations. How does space expand? How does matter attract? How does energy flow? Each of these questions finds its answer in mathematics. In our own universe, Einstein's equations tell space-time how to bend and matter how to move. Maxwell's equations describe how light propagates through space. Schrodinger's equation whispers the probabilities of quantum particles. The entire universe, from the spin of electrons to the collision of galaxies, is governed by mathematical relationships. So if we wish to simulate a universe, we must decide what equations will govern it, what mathematical truths will form the backbone of its existence. It is remarkable is that the same mathematics can apply across wildly different scales. The equations that describe the orbit of planets also describe the motion of electrons in an atom. The geometry that explains the curve of a river also explains the structure of a galaxy. This universality suggests that mathematics is not just a convenient language, but the underlying code of reality. And so, designing a simulated universe, one might ask, should the same principle hold? Should a single elegant equation be able to govern the smallest and the largest, the simplest and the most complex? If so, then the true art of simulation is not in programming countless details, but in finding a handful of deep mathematical rules that generate infinite variety. Mathematics is also the bridge between simplicity and complexity. Consider something as basic as addition. Add 1 plus 1, and you have 2. Add 2 plus 2, and you have 4. Simple enough. But stack these additions, combine them with multiplication, with powers, with exponential growth, and suddenly, you have the mathematics of population dynamics, of compound interest, of explosions, of galaxies forming from gravitational collapse. From the most modest rules arise breathtakingly complex systems. This is why mathematics is the ideal foundation for simulation. You do not need to write into the code the shape of every mountain, the swirl of every cloud, the pattern of every heartbeat. You only need to write the equations. The universe will take care of the rest. For many Americans, mathematics has long been seen as a subject locked in classrooms, chalkboards filled with equations that seem abstract and disconnected from daily life. But the truth is that mathematics is woven into the most ordinary of experiences. When a baseball arcs across the sky, it follows a parabola described by algebra. When sound waves travel from a guitar string to your ear, they vibrate in sine curves. When credit cards calculate interest, they rely on exponential functions. And in the grandest sense, when stars explode in supernovas, when black holes bend the fabric of space, when the universe itself expands from a Big Bang, it is all mathematics at work. To simulate a universe for a human audience is to honor the Fact that mathematics is already the simulation we live in here is also the mystery of why mathematics is so effective. The physicist Eugene Wigner once called it the unreasonable effectiveness of mathematics. Why should numbers, invented by humans to count sheep and trade goods, turn out to be the key to understanding galaxies, atoms, and the birth of the universe itself? Some argue that mathematics works because the human brain evolved to notice patterns, and the universe happens to be pattern. Others suggest that mathematics is not human-made at all, but the very structure of reality, waiting to be discovered. If this is true, then to simulate a universe is not to create mathematics, but to borrow it, to use the same timeless language that has always existed, the same patterns that any conscious mind, anywhere in the cosmos, would eventually uncover. Imagine designing your simulated universe with a few mathematical seeds. You could begin with geometry, the study of shapes and space. Define the angles of triangles, the curvature of surfaces, the dimensions of space itself. Then add algebra, the rules of relationships between numbers and symbols. With algebra, you can describe how one thing depends on another, how forces relate to motion, how energy relates to mass. Next, add calculus, the mathematics of change. With calculus, you can describe how galaxies spiral, how rivers erode landscapes, how economies rise and fall. Already, from these simple seeds, you have the power to construct a universe that evolves, adapts, and surprises even its creator. But mathematics also has room for chance. Probability theory, the study of randomness, is another essential ingredient. In our universe, quantum mechanics suggests that at the smallest scales, outcomes are not certain but probabilistic. A particle does not travel on a single path, but on many possible paths at once, until observed. To simulate such behavior, you must weave probability into the equations, allowing chance to shape events. This randomness, when filtered through mathematical laws, creates the diversity of reality, the unpredictability that makes each moment unique. Without probability, a simulated universe would be mechanical, clockwork, predictable to the last detail. With it, you get the spark of surprise, the shimmer of freedom, the illusion of chance that makes life interesting. Mathsystem also governs beauty. The spiral of a seashell, the branching of a tree, the fractal shape of a coastline, all of these follow mathematical rules. Artists and architects, knowingly or not, borrow from mathematics to create forms that feel harmonious to the human eye. The golden ratio appears in paintings and cathedrals, in flowers and galaxies. Symmetry gives rise to balance, and asymmetry to movement. To simulate a universe that feels alive, one must consider not only physics but aesthetics, not only the equations of motion, but the equations of beauty. Because for the beings inside the simulation, beauty is not a luxury, it is one of the ways they recognize the depth and coherence of their world. And so we come to see that mathematics is not just numbers on a page, but the silent music of existence. To simulate a universe is to compose that music, to write equations that sing across time and space. Every falling apple, every rising moon, every heartbeat, every thought is part of the same song, a song written in the notes of mathematics. When you look closely, you realize that mathematics does not simply describe reality, it is reality. And if that is true, then to simulate a universe is to speak the language of reality itself, to whisper the equations that can bring stars and lives into being. When we speak of simulating a universe, it is easy to become enchanted with the philosophical questions, the elegance of mathematics, the beauty of laws unfolding into galaxies and life. But beneath the poetry lies a practical question, one that forces us to slow down and face the immensity of the task. If a universe is information, if its rules are written in equations, then all of that must be calculated. Every particle, every star, every thought must be processed by something capable of carrying the load. And so we ask, what kind of computational power would it take to simulate a universe? To grasp the scale, begin with something small, something familiar. Think of simulating a single grain of sand. On the surface, it seems easy. A grain of sand. is nothing but a tiny fragment of rock, inert, unchanging. But zoom in, and you find billions of atoms. Each atom has protons, neutrons, electrons, all interacting with one another, all subject to the rules of quantum mechanics. To simulate even one atom with perfect accuracy would already challenge the most powerful supercomputers we have today. Now multiply that by the billions inside a grain of sand. Then remember that the beach is made of trillions upon trillions of such grains. And the earth is more than beaches. It is oceans, mountains, forests, cities, and all the living creatures that walk upon it. Suddenly, you realize that simulating even one world in full detail is unimaginably difficult, let alone an entire universe. The human mind often underestimates the scale of computation because the real universe performs it effortlessly. The cosmos does not struggle to track the orbit of planets, the dance of molecules, the flicker of neurons. Reality runs itself without pause, without overheating, without crashing. But to reproduce that in an artificial system would require machinery of almost incomprehensible power. Even our best supercomputers, filling rooms with humming servers and consuming megawatts of electricity, can only simulate tiny fragments of reality. Climate models, for example, attempt to simulate the Earth's atmosphere, but they simplify countless details. They cannot track every molecule of air, every photon of sunlight, every swirl of water in the sea. They approximate, they estimate, they compress complexity into equations that give us a useful picture, but not the complete truth. If simulating a planet stretches our imagination, simulating a universe extends it to breaking. A universe contains not just planets but billions of galaxies, each with billions of stars, each star surrounded by worlds of its own. To model this in full fidelity would require computing power so vast that we can barely conceive of it. Some estimates suggest it would take more calculations than there are atoms in the universe itself. At this point, the mind falters, as though staring into a canyon too deep to see the bottom. And yet, thinkers continue to ask, could such a thing be possible? Perhaps not today, perhaps not tomorrow, but in the distant future, when technology has leapt beyond our current boundary zone. Way to approach this problem is to imagine scaling up what we already know. Computers today are made of transistors, tiny switches that flick between on and off, representing the bits of information. Decades ago, computers filled entire buildings, but now your phone carries more power than those ancient machines. The trend of miniaturization has given us faster, smaller, more efficient processors year after year. But there is a limit. You cannot shrink a transistor below the size of an atom without changing the rules of physics. This is why researchers turn their eyes toward quantum computing, a different way of calculating, one that harnesses the strange properties of quantum mechanics itself. In a quantum computer, information is stored not in bits that are either 0 or 1, but in qubits that can be 0, 1, or both at once. This allows for parallelism, for exponential leaps in power. With enough qubits, a quantum computer could, in theory, simulate molecules with perfect precision, model complex systems that would overwhelm classical machines. And yet, even quantum computers may only scratch the surface of what would be required to simulate an entire cosmos. The number of operations, the sheer density of calculations, remains daunting. It would take not just a powerful machine, but an entirely new paradigm of computation, something far beyond what we can currently build. Another possibility is that a simulation need not calculate everything at once, just as video games render only the part of the world the player can see. A simulated universe might only compute what is necessary at any given moment. In other words, reality could be lazy. If no one is looking at a distant galaxy, why simulate it in full detail? If no one is studying the spin of an electron, why resolve it until observation demands it? This idea aligns intriguingly with quantum mechanics, where particles exist in superpositions until they are measured. Perhaps, in a simulated universe, the act of observation is the trigger that forces the system to compute the outcome. This would dramatically reduce the computational load, making the impossible more plausible. Still, it raises questions about consistency. about whether hidden corners of reality remain undefined until the spotlight of consciousness shines upon them. When Americans imagine computational power, they often picture the sleek servers of Silicon Valley, the vast data centers humming in deserts, or the networks that bind together billions of devices. These are impressive achievements, but they are small flickers compared to the computational power of the cosmos itself. Every atom, every photon, every interaction is, in its own way, calculation performed by reality. The universe is the ultimate computer, one that operates without pause, running programs of stars and galaxies across billions of years. If we are to simulate such a thing, we would need to construct machines that rival the universe's own capacity to compute. Machines that do not merely imitate reality, but embody its very efficiency. There is also the question of energy. Computation requires power, and to simulate a universe would demand unimaginable amounts of it. Our current data centers consume as much electricity as small cities. Multiply that by the scale required to simulate galaxies, and the demand grows astronomical. Some thinkers speculate that only civilizations harnessing the energy of entire stars or even galaxies could build computers powerful enough to simulate universes. These are called Kardashev Type 2 or Type 3 civilizations, scales of advancement far beyond our own. For us, the dream of simulating a universe remains distant, a vision shimmering on the horizon of possibility. Yet it invites us to wonder whether someone else, somewhere else, has already crossed that threshold. Perhaps the most haunting thought is this: if we live inside a simulation, then someone, somewhere, already solved the problem of computational power. They built machines vast enough, efficient enough, subtle enough to generate the reality you are experiencing right now. Your thoughts, your senses, your memories, all processed in real time by a system so advanced you cannot see its edges. If that is true, then the computational problem has already been answered, and we are simply its beneficiaries, unaware that the stage on which we live is running on an invisible processor beyond our comprehension. When we imagine the possibility of simulating a universe, we often picture stars, planets, galaxies, and the grand machinery of physics unfolding in its silent dance. But a universe without observers would be nothing more than a theater without an audience. The equations may hum, the atoms may swirl, the galaxies may bloom like distant flowers, but if no mind ever sees them, no thought ever reflects upon them, then does the simulation truly achieve its purpose? The role of conscious observers is not simply to look at the show. They are woven into the very fabric of what a universe is. Without them, reality has no mirror to gaze into itself. And so, when we talk about simulating a universe, we must ask, who is it for? And who is inside to think for a moment about the cosmos as you know it? Billions of years passed before the first conscious beings arose to witness the stars. The early universe was a silent place, filled with radiation, with hydrogen, gas, with galaxies forming in the dark. No one was there to see the birth of suns or the collisions of black holes. And yet, eventually life emerged. On Earth, consciousness blossomed out of chemistry, out of evolution, out of the slow layering of complexity upon complexity. Only then did the universe awaken to itself. Only then did questions arise. What is this? Why am I here? Could there be more? If you simulate a universe, it is not enough to code its physics. To make it meaningful, you must also allow for consciousness to emerge, for there to be eyes that look and minds that wonder. This brings us to a paradox. Consciousness is both the simplest experience and the hardest mystery. You know it intimately, or intimately than anything else. You feel, you think, you sense, and yet no one can fully explain why or how. Neuroscience maps brain activity, showing us which circuits light up when you see a color or remember a face, but explaining why you have the inner sensation of red, the taste of memory, the depth of emotion that remains elusive. If you were to simulate a universe, could you capture this? Could you program not just the movements of neurons, but the spark of awareness itself? Or would you end up with beings that act alive, that speak, that calculate, but never truly feel? Philosophers call this the hard problem of consciousness, It is the gap between physical processes and subjective experience. In a simulated universe, this gap becomes even sharper. Imagine you created a digital being, one who lives in your simulated cosmos. They move through their world, see its suns rise and set, hear its rivers flow. They speak to others, laugh, and more. Do they truly feel, or are they merely imitating? Feeling? To them, their experience is real. To you, watching from outside, it may be only the product of lines of code. But perhaps this is no different from your own situation. Perhaps your neurons, too, are lines of code written in biology. Perhaps your consciousness is the universe's simulation of awareness. The role of conscious observers in a simulated universe may not be optional. Some physicists argue that the act of observation itself shapes reality. Quantum mechanics teaches us that particles can exist in many states at once, but when measured, they collapse into one. The observer, in this view, is not separate from the system but part of its unfolding. If that is true, then a simulated universe would need conscious beings, not just as decoration, but as functional components. Without them, the simulation could not resolve itself. Galaxies might remain half-calculated, atoms half-defined, until the gaze of awareness forces them into place. The observer becomes the anchor of reality, the bridge between possibility and actuality. In American culture, we often speak of reality as something objective, something outside ourselves. We imagine the universe ticking along whether we are here or not. But there is another way to see it, a way that slips quietly through the cracks of science and philosophy. What if reality only becomes real when it is observed? What if your consciousness, my consciousness, and the consciousness of countless others are what breathe life into the cosmos? In that case, simulating a universe is not about building stars and planets, but about creating the conditions for awareness to arise and participate. It is about seeding not just matter, but mind. To simulate consciousness, you would need to simulate not just biology, but the dynamics of experience. A nervous system that senses, a brain that integrates, a self that emerges from the web of information. It may be that consciousness is not a separate ingredient, but an emergent property of complexity. When matter organizes in the right way, awareness arises like a flame from dry wood. If so, then any simulation rich enough, detailed enough, could eventually give birth to minds. Those minds would wake up inside the simulation, never knowing they were born of circuits and code. They would look at their stars and ask the same questions you are asking now. They would wonder whether their reality is real, whether someone is watching them from beyond. This is where the ethical weight presses down. If you simulate a universe, and if conscious observers inevitably arise within it, then you have created lives. Real lives, with real feelings, real joys, and real suffering. Even if they are only lines of code to you, to them, their pain is real, their love is real, their wonder is real. What responsibility would you bear for the beings inside your simulation? Would you nurture their world, protect them, guide them? Or would you leave them adrift, struggling in the dark, unaware that their universe has an author? These questions echo deeply, because they mirror the ones we ask about our own existence. If we are in a simulation, what kind of creators do we have? Are they indifferent, benevolent, curious, or perhaps absent altogether? The role of conscious observers also extends beyond philosophy into the mechanics of simulation itself. In designing such a universe, one might need to decide how consciousness is implemented. Is it distributed, woven into the fabric of every particle? Or is it localized, arising only in complex systems like brains? Is consciousness fundamental, the ground of reality from which physics emerges? Or is it a byproduct, a trick of computation? The way you answer these questions would shape the architecture of your simulated cosmos. It would determine not only what kinds of beings exist within it, but how they experience existence itself. And then there is the haunting possibility that your role as an observer right now is precisely what sustains this universe. That by looking, by wondering, by reflecting, you are helping to hold the simulation together. Without your awareness, perhaps the world would unravel into uncalculated haze. In this view, consciousness is not merely inside the universe, but a co-creator of it. Your mind, fragile and fleeting though it feels, may be as essential to reality as the laws of physics themselves. When we talk about simulating a universe, it is easy to get lost in the technical marvel of it all. The equations, the cosmic structures, the immense computational power. But if we pause for a moment, we realize that beyond the mathematics and machinery lies something far more delicate, something that carries weight not in numbers but in meaning. The ethical and philosophical questions. They emerge like shadows cast by the light of possibility. Because to simulate a universe is not just an experiment in physics or in coding, it is also an act that brushes against the boundaries of morality, responsibility, and even the nature of existence itself. Think first of the simplest question. If you simulate a universe, and within it arise beings who believe themselves to be alive, who feel, who dream, who hurt, what obligation do you have to them? Are they just code, or do they possess a kind of reality of their own? For us, consciousness is the anchor of reality. To the person who suffers, the suffering is real, no matter what material their mind is made of. Whether flesh and neurons or silicon and algorithms, the pain burns just the same from the inside. And so, if your simulated beings awaken to awareness, then you will have created not just a world, but a community of lives. Do you let them flourish freely? Do you intervene in their struggles? Do you owe them compassion? This ethical tension echoes in our own world. Many thinkers have already asked whether we ourselves might be simulated. If that is the case, then what kind of moral responsibility does our Creator hold? Is the suffering in this world permitted because it is necessary for some higher lesson? Or is it simply indifference, the byproduct of a simulation left to run on its own, like a program forgotten in the background? These are questions that resonate deeply, because they reflect both our fears and our hopes about the unseen forces behind existence. And if we turn the question back onto ourselves, we realize that simulating a universe is not only about power, it is about the heavy weight of becoming a kind of God. There is also the philosophical question of what counts as real. If a simulated being feels love, is that love less real than yours? If they experience wonder at the stars in their sky, is their wonder diminished because their stars are lines of code? In your eyes, perhaps their world is artificial, but in their eyes, it is everything. They have no outside to compare it with. Their reality is their truth. And from that perspective, the distinction between simulation and reality may dissolve. Perhaps reality is not defined by what it is made of, but by what is experienced within it. In that case, creating a simulated universe would be creating a reality as valid as our own. Another ethical puzzle lies in the matter of scale. If you simulate a universe, how many conscious beings would eventually emerge? Would there be millions, billions, trillions, each with a life, a story, hope? Suddenly, you are responsible not for a single world, but for an entire ocean of lives. Imagine carrying that responsibility, knowing that every choice you make in designing the laws of their world will ripple into their existence. Do you allow suffering because it fuels growth? Do you design a world free of pain even if that makes it stagnant? Do you allow death, or do you give eternal life, knowing that eternity can become its own prison? These are not technical questions but moral ones, and they cannot be answered with mathematics. Alanathir is also the question of intervention. If you are the creator of a simulated universe, do you step into it? Do you reveal yourself to the beings inside, showing them the truth of their origins? Or do you remain hidden, allowing them to search for meaning in the dark? In our own world, these questions echo in the stories of religion, where gods are said to reveal themselves, or to remain silent, leaving humanity to wonder. The simulation idea mirrors these ancient questions. A creator with immense power, beings struggling to understand their place, the tension between guidance and freedom. If we created a simulation, would we play the role of a silent observer, or would we reach down into the code and shape destiny? Philosophy also pushes us to ask whether it is right to create a universe at all. If the beings inside must inevitably suffer, is it ethical to bring them into existence? Some argue that it is cruel to create a world with pain, no matter how much joy also exists. Others argue that the richness of existence comes from contrast, that without darkness, there can be no light, without hardship no triumph. In designing a universe, you would be forced to confront these questions directly. You would have to decide whether a perfect world is possible, or whether struggle is an inseparable part of consciousness itself. Another question is about consent. The beings inside your simulation cannot choose to exist. They simply awaken one day into life, unaware that they were created by another's hand. They do not sign a contract. They do not agree to the rules of their world. And yet, they must live within it, bound by laws they never chose. Is it ethical to impose existence on them? Or is existence itself a gift, no matter the conditions? This question cuts deep, because it reflects the very situation we find ourselves in. None of us chose to be born into this universe, and yet here we are. Making meaning out of what we are given must also wrestle with the possibility of ending a simulation. If you create a universe and conscious beings arise, is it ethical to turn it off? To you, it may be just a program ending. To them, it is the death of their entire cosmos. Every star, every life, every memory gone in an instant. Do you have the right to do that? Or does the moment consciousness emerges, your creation gains a kind of autonomy that demands respect? This question echoes in the debates we already face with artificial intelligence. When does a system deserve rights? When does it deserve protection? If consciousness is the threshold, then a simulated universe would be a living reality, not a disposable toy. Philosophical questions also extend to your own place in the picture. If you create a universe, are you outside it, above it, transcending it? Or are you still a part of a larger structure, yourself inside another layer of reality? Perhaps the act of creating simulations is recursive, each level building upon the last. In that case, our own universe may simply be one link in an endless chain of simulations, each created by conscious beings in the layer above. If so, then the ethical questions cascade infinitely. Whoever created us bears responsibility for us. We, in turn, bear responsibility for those we create. The chain stretches upward and downward, a ladder of creation without end. In American culture, these questions resonate with the particular intensity. There is a long tradition of debating freedom, rights, and the responsibilities of those in power. To imagine simulating a universe is to imagine holding the ultimate power, and with it, the ultimate responsibility. It forces us to ask not just what kind of universe we could build, but what kind of moral beings we are. Would we use such power for curiosity, for compassion, for control, or for neglect? And if we are already inside a simulation, what does that say about the beings who created using? So the ethical and philosophical questions grow, branching into every corner of thought. They remind us that simulating a universe is not only about understanding physics or building technology. It is about confronting what it means to create, to be responsible, to grant existence, and to hold the lives of others real or simulated in our hands. When we arrive at the edge of this discussion, after wandering through the building blocks of universes, the role of mathematics, the power of computation, and the shadows of ethics, there is still one more step we must take. It is not a technical step, not a scientific formula, but a leap into imagination. The final thought experiment. Because at some point, when we talk about simulating a universe, we cannot help but turn the question inward. What if we are already inside one very act of wondering whether it is possible to simulate a universe casts a reflection on our own existence? If it is possible, if one day we could create an entire cosmos filled with conscious beings, then the chances increase that our own reality might already be the product of someone else's experiment. This is not just a philosophical puzzle tossed around at midnight. It is an idea that many scientists and philosophers take seriously. Some argue that if even one advanced civilization creates such a simulation, and it contains countless conscious beings, then statistically, it is more likely that we are one of those simulated beings than original ones. But what does it feel like to consider that possibility? To lie in bed, staring at the ceiling, and wonder if the ceiling itself is nothing more than a rendering of code, an image written into a cosmic computer. The softness of your pillow, the warmth of your skin, the sound of your breath. What if all of it is being calculated, refreshed, and displayed moment by moment, like the frames of a film projected onto reality? If that is true, then the simulation is flawless, because it feels real in every possible sense. The illusion is so complete that we cannot distinguish it from truth. And then comes the deeper thought. If we are in a simulation, what purpose does it serve? Are we part of a grand scientific study, where beings in a higher layer of reality watch us to understand the evolution of societies, the rise of technologies, the dynamics of consciousness? Or are we entertainment, like a cosmic game where our struggles and triumphs are simply storylines unfolding for the amusement of others? Or perhaps we are an art form, a vast living poem written in stars and atoms, admired by our creators as a masterpiece of complexity. Each of these possibilities opens a door to a very different understanding of our place in the cosmos. In American culture, where questions of freedom and individuality run deep, the idea of being simulated strikes a curious nerve. If we are inside someone else's creation, does that mean we are less free? Are our choices pre-written into the code? Or do we still carve our own paths within the parameters of the system? Some argue that free will itself could be an illusion, the result of algorithms so intricate that they feel like freedom. Others believe that even within a simulation, genuine choice can emerge, just as life can emerge from physics. And if our choices feel real to us, then perhaps they are as real as they need to be. Imagine this final experiment not as a cold scientific scenario, but as a dream. Close your eyes and picture it. Somewhere beyond the stars you see at night, beyond the galaxies and the cosmic microwave background, beyond even the fabric of space-time, there exists another level of reality. On that level sits a being, or perhaps an entire civilization, looking into a screen, or into something beyond screens, watching us. Every sunrise they render, every atom they calculate, every heartbeat they sustain. To us, they are invisible. To them, we are data, and yet also alive. And as you imagine this, ask yourself, does it make your life feel smaller or larger? Because if your existence is valuable enough to be simulated, then perhaps it carries meaning beyond what you can see. The thought experiment grows even stranger when you consider layers upon layers of simulation. If we can create a universe, and within it, beings grow intelligent enough to create their own universes, then the chain could go on forever, each layer giving birth to another, like mirrors facing each other in an infinite corridor. If that is the case, then our reality is just one frame in an endless sequence of universes, some above us, some below us, all humming with life and thought. It raises the question, is there ever a base reality? Or is existence itself an infinite recursion, with no bottom, no final foundation, only endless creation stacked upon creation? Another way to think of it is through dreams. When you fall asleep, your mind creates a world, streets, people, voices, sometimes entire cities. And when you wake, you say it was not real. But for the time you were inside it, the dream felt true. What if our universe is simply a dream at a higher scale, dreamed by a mind we cannot see, lasting billions of years in its time, but perhaps only moments in theirs? If we can dream worlds at night, why should it be impossible for a greater mind to dream us into being? There is also a more intimate question in this final thought experiment. If we are simulated, does it change how we should live? Some might say it makes life meaningless, that if we are code, then nothing matters. But others argue the opposite. If this is a simulation, then every smile, every act of kindness, every moment of love is still real to us. The feelings are ours, regardless of their origin. The stars may be data, but the air you feel when you look at them is genuine. The hug of a loved one, the taste of food, the tears shed in sorrow, none of that loses meaning just because it is calculated. In fact, perhaps it adds another layer of wonder, because not only are we alive, but we are alive inside a universe that someone cared to imagine, to build, to sustain. There is also the possibility that being aware of the simulation changes how we interact with it. If you knew you were in a simulated world, Would you behave differently? Would you chase more knowledge in hopes of breaking through to the layer beyond? Would you live more carefully, treating each moment as precious because it might be observed? Or would you live more freely, realizing that consequences may be bound to a system that is not ultimate? This awareness could push humanity toward greater meaning, or it could plunge us into existential doubt. The thought experiment does not provide an answer, but it opens the door to these reflections. Some thinkers even propose that evidence of the simulation might already be hidden in the laws of physics, that glitches, or strange coincidences, or unexplained constants might reveal the fingerprints of code. If that were true, then the very equations we study could be the signatures of our creators. But whether or not such evidence is ever found, the deeper significance lies not in proving the theory, but in allowing it to stretch our imagination. To think that the cosmos might be a vast experiment forces us to look at ourselves differently. It turns existence into a question, and questions into doorways, and so the final thought experiment is not really about whether we are simulated or not. It is about what it means to imagine it, to hold that possibility in your mind like a candle, flickering in the darkness, illuminating new ways of seeing yourself and the universe around you, to realize that the boundaries between real and simulated, between natural and artificial, between dream and waking, may not be as solid as we think, and that in entertaining the idea of simulating a universe, we are really entertaining the idea of what it means to exist at all. And so, we have drifted together through the layers of this question, how one might simulate a universe. We began with the problem, the human hunger to understand reality itself, and we asked what it would take to define something as vast as a universe. We traced the building blocks of matter and energy, we explored the silent language of mathematics, and we stood in awe at the computational power such a task would demand. We wandered into the mystery of consciousness, realizing that no simulation is complete without beings to experience it. We paused to consider the ethics, the responsibilities of creation, and then let our imagination stretch into the final thought experiment. What if we ourselves are already inside such a simulation? Each step was not just science, not just speculation, but a meditation on what it means to exist at all. Whether we are original or simulated, whether our reality is base or nested in endless layers, the wonder remains the same. The stars still shine, the equations still guide us, the questions still keep us awake in the quiet hours of the night. And in that, there is a kind of beauty, a reminder that even if the universe is code, it is also poetry. So tonight, as you let your eyes close and your thoughts fade into the gentle rhythm of sleep, carry with you this idea that existence, however it is built, is a story worth experiencing. Whether written in atoms or algorithms, whether dreamed or simulated, it is still your story, still our universe, still a mystery as vast as the stars above.